Hello everybody, today we'll solve one example problem. It will show you how to calculate shear stress in a beam. You can see on the screen a wooden beam. The cross section of this beam 100 mm by 125 mm. It is subjected to internal vertical shear force of 3 kN. We have to calculate the shear stress at point P at this level and also the maximum shear stress in this beam. When you have to calculate the shear stress in a beam, you have to use the shear stress formula. What is the shear stress formula? As you know, the shear stress formula is tau equals to VQ over IB. To apply this formula, you need to know what is V, what is Q, what is I, and what is B. V is the internal shear force, and for this example, this V value is given. It is 3 kN. I value you can calculate from the cross section. For a rectangular cross section, I value is BH cube divided by 12. So we will able to calculate I value from this cross sectional dimension. B value is the width of the beam. This is the width of the beam. It is 100 mm. And Q is first moment of area at the considering point. If you need to calculate the shear stress here, you have to calculate the first moment of area about the neutral axis for this area. We'll learn how to calculate Q value. That is the critical part to solve this problem. So let's see how we can do that one. You can see this is the P point. You can take it from the top to this P point, or you can take from the bottom to this P point. Anyway you can go, but we'll go from the top to this P point, that is this darker area. The definition of Q is this A dash multiplied by Y bar. Y bar is from the centroid to the neutral axis, the distance from the centroid of this area to the neutral axis. It is first moment, that means area moment. You have to take the area and its moment about to the neutral axis. So what is the area? Area is 100 multiplied by 50. You can see this area 100 multiplied by 50, and moment arm will be 12.5 plus 50 divided by 2. That means this distance from the centroid of the area to the neutral axis. The calculation of Q will be, this is the area 50 multiplied by 100, and this is the distance 12.5 plus 50 divided by 2. You will get the Q value. Obviously the I value is BH cube divided by 12. You can calculate as on the screen. It is 16.28 into 10 to the power 6 millimeter to the power 4. Now we have V value, Q value, I value, and V value, so we can calculate the shear stress. And finally the shear stress, if you plug in all the value in this formula, we'll get this shear stress at point P will be 0.346 MPa. In the second part, we'll calculate the maximum shear stress in a beam. So to calculate the maximum shear stress, you have to know that the maximum shear stress occur at the neutral axis location of the beam for rectangular cross section. We have rectangular cross section. Our maximum shear stress will occur at this location. We have to find the Q value considering this darker area. So how to calculate the Q value? You have to take this area, and the area is 100 multiplied by 62.5. You can see 100 multiplied by 62.5. And this area's moment about the neutral axis. That means from this centroid of this area to the neutral axis. That means 62.5 divided by 2. So that will be your distance. The distance multiplied by area will give you the Q value. When you have the Q value, you have already calculated the I value. you know the V value, then you can calculate the shear stress. And maximum shear stress will be, you plug in all this value, you will get V multiplied by Q divided by I multiplied by T. V is 3 kilonewton, Q is 19.53 into 10 to the power 4 millimeter cube. I is 16.28 into 10 to the power 6 millimeter to the power 4, and B or T equals to 100 millimeter. We are calculating by putting all this value in kilonewton and millimeter. So our result will come 3.6 into 10 to the power minus 4 kilonewton per millimeter square. If you multiply it by 1000, it will come 0.360 MPa. Instead of using this one, if you can remember the formula given in your text, equation number 49 of your text, then you can directly calculate the maximum shear stress using that formula. And what is that formula? Maximum shear stress, tau max, equals to 3 divided by 2 V divided by A. That means maximum shear stress in a rectangular section is 1.5 times the average shear stress. Want to use directly that formula, you can use that one also, and we'll get the same result. The tau max equals to 1.5 V divided by A. V is 3 kilonewton, A is 100 multiplied by 125, and you will get 0.36 MPa.